next is part 184, line 18a4b Alfvén Magnetosonic Hydromagnetic Plasma Wave Wow Seti. So there's the alien radio signal, and again, this is going to be full of lots of data, okay? So these are quotes from Wikipedia. An Alfvén wave named after Hans Alfvén is a type of magnet hydrodynamic wave. An Alfvén wave is in a plasma is a low frequency compared to the ion cyclotron frequency traveling oscillation of the ions and the magnetic field. The ion mass density provides the inertia, and the magnetic field line tension provides the restoring force. The wave propagates in the direction of the magnetic field, although waves exist at oblique incidence and smoothly change into the magnetosonic wave when the propagation is perpendicular to the magnetic field. The motion of the ions and the perturbation of the magnetic fields are in the same direction and transverse to the direction of propagation. The wave is dispersionless. So there's the Alfvén velocity. That's what it looks like. There's some more stuff there. You can look that up on Wikipedia, okay? So the wave travels through the chromosphere and transition zone and interacts with much of the ionized plasma. The wave itself carries energy as well as some of the electrically charged plasma. DuPont and Herendell suggested in the early 1990s that Alfvén waves may be associated with the plasma jets known as spicules. It was theorized with these short-lasting spurts of superheated gas were carried by the combined energy of and momentum of their own upward velocity as well as the oscillating transverse motion of the Alfvén waves. In 2007, Alfvén waves were reportedly observed for the first time traveling towards the corona by Tomczyk et al., but their predictions could not conclude that the energy carried by the Alfvén waves were sufficient enough to heat the corona to its enormous temperatures, for the observed amplitudes of the waves were not high enough. However, in 2011, McIntosh et al. Reported the observation of highly energetic Alfvén waves combined with energetic spicules, which could sustain heating the corona to its 1,000,000 Kelvin temperature. Wow, it's hot. These observed amplitudes, 200 or 20, okay, let's go there. I'm not going to try to read it. Okay, the short period of the waves also allow more energy transfer into the coronal atmosphere. The 50,000 kilometer long spicules may also play a part in accelerating the solar wind past the corona. So next thing is hydromagnetic wave. This comes up. This is a keyword. A wave in which both the plasma and the magnetic field oscillate. The speed at which hydromagnetic waves are propagated along a magnetic field is that. And it's from this website here. Okay. And there's a picture showing you what it looks like. So this is a schematic of the Birkeland or field-aligned currents and the ionospheric current systems that connect to. There you go. Quotes from Wiki. A Birkeland current is a set of currents which flow along the geomagnetic field line connecting the Earth's magnetosphere to the Earth's high altitude ionosphere. They are a specific class of magnetic field-aligned currents. Lately, the term Birkeland currents has been expanded by some authors to include magnetic field-aligned currents in general space plasmas. In the Earth's magnetosphere, the currents are driven by the solar wind, an interplanetary magnetic field, and by bulk motions of plasma through the magnetosphere. Convection, which is indirectly driven by the interplanetary environment. The strength of the Birkeland currents changes with activity in the magnetosphere during substorms. So that's the end of that video. You can see the tags there. We'll go on to our next one.